Hey, my name is Marcus Burton.
Hey, I'm GT Hill.
Hey, thanks so much for joining us. In our last video, we talked about the different as-a-service models. Hopefully you didn't tune out on that. And we're going to talk about cloud deployment models. We realized in that conversation that we would like to circle back, so we lied about what we're going to do next. We want to talk about functions as a service, which is also well known as serverless computing.
Functions as a service. We have lots more services. I actually have decided that this may be my last video, Marcus. I'm starting a new business called TP as a service, toilet paper as a service. I'm sure you're excited about that. I'll let you in on the deal if it ends up being okay. But speaking of toilet paper, so it's a big topic of discussion right now. But if you think about how to buy something, right? When you purchase a thing, we're going to use toilet paper as an example. You can buy it in really three different ways. So I'm going to draw this out here. So you can buy it in bulk, where you have lots and lots of toilet paper. You fill up a truck full. So you can buy it in bulk. And then, the other way to buy it is, like maybe a more reasonable person. I mean, I'm not reasonable. I buy stuff in bulk, so I throw myself in that category. Maybe you buy a package of it. It's got, 9 rolls in it. But those 9 rolls are just as good as 20. And then your last way to do it is Marcus, you can't see this, but I'm drawing a toilet. The last way to do it is moment of use. So maybe you have to, you're at a restaurant and they charge you per time you're using it. This is probably the worst analogy I've ever done, but that's okay. So, you purchase it kind of like a regular person. So why are we talking about that? There has to be a reason.
Well, yeah, those 3 ways to buy toilet paper or something basically are equivalent to 3 ways that you can buy compute in the cloud. And so the 3 models and the way that we sort of map them to those toilet paper as a service models, the first one is like having an always on container or an always on VM. So you're buying compute on a time basis, and it's just always there, always available. And that second model is a little bit like a sort of dynamic container that you can bring up and take down as needed as load and capacity change. And then that third model is similar to functions as a service, which we call serverless.
All right, so I drew this out. Always on VM and container. We got some dynamic. It's also called orchestration, which you actually have talked about before. Is that Kubernetes that does the orchestration part?
Yeah. Yep.
Look at me. Right. Oh, look at me. And then we have serverless, which what I've drawn for serverless is nothing, because apparently I have nothing to draw for something that doesn't exist. So maybe I'll fill that in sometime later.
And I think the analogy itself, we almost have to treat as if buying toilet paper in bulk, it has an expiration. So it's like we're buying in bulk, but we also have to use all that toilet paper this month.
Right. We could have used something like lettuce or something like that, but that's not nearly as fun to talk about. All right. So both the VM and container and the dynamic version, we're saying has an expiration that you're going to pay something for that. But it has a limited use as opposed to toilet paper, which they last as long as Twinkies probably.
So you have to almost then think and bridge the gap to sort of these models. We described them quickly, but if you think about like a network management application, think about this full-time VM container sort of paradigm. That first paradigm is what we would use for some service that we know is always going to be on. There's always some demand for it within the network system. It might be events or logging, or there's other, features like tunnel management, session management. We just know there's always going to be load on that. So we want to keep that service always on. That second one might be for different types of dynamic load, things that come and go with user density changes. In the middle of the night, we might not have load that's applied to that service, so we can spin it down. And then serverless, you can think of as sort of event-driven compute tasks. So things that are intermittent, they come and go very dynamically. It might be something like creating a key or deleting a user, or something that's very event-driven, and it happens very quickly.
Here's a way to look at this. By the way, these numbers are not accurate of how much it actually costs. These are just numbers we threw in for illustration purposes. So $10 a day which equals about 41 cents an hour, is our fictitious what we would pay for a VM or container. On the dynamic where it's orchestrated, that's $1 per hour of use. So if you don't use it, it's nothing. If you spin one up, it costs you $1 an hour. And then serverless, that's 5 cents per compute minute for just, it's just being used. That's 5 cents, which comes out to $3 per hour. So if you think about that in chili cents, remember that this can expire. So you may say, well, I just always want to, pay 41 cents an hour. That's a lot less expensive. But it's not if you don't use it. So if I buy 2 cases of chili but only eat 1 can, that's wasteful, right? My per can cost now goes way up. So it doesn't make sense for me to do this here in number one VM or container. And the same thing can happen even with your dynamic containers, that if I spin one up for an hour but it's only used for 30 seconds, that also doesn't make economic sense. I probably should have gone to my model number 3, which is serverless, and just save myself a lot of money.
Yeah, and when you look at the way the applications are constructed, that there are certainly some things that can become serverless in order to gain those efficiencies. Some things that just never need to always be on, that if you run them only at the time that they need to be run, you save a lot of costs. So it sort of becomes a dance within an application to figure out which model works best.
Yeah, and we've talked about number 1 and number 2. We've never put numbers to it, which I'm happy we did. I think that maybe starts to make this, even our containers video, understanding this a little bit more.
Yep.
But we haven't really defined serverless yet. We've done that on purpose.
Yeah.
We're kind of holding off on that. So how does it actually work, and why is it serverless?
Well, so if you think about the way that cloud companies operate, so they have, even what we call the cloud is basically just, everyone wants to say it's just someone else's computer, but even though we say it's serverless, it's really a cloud operator that's making pods of compute available for consumption in a different model. So it's the same underlying stuff in terms of the servers and the hardware and all that sort of is under the whole operation, but it's just made available on a per use, on demand, event driven cycle. So you basically write some code and then you just call an API, let's say to Google's, functions as a service. You call an API to say, we want this code to run based on this one specific event. They run the code for you, and that's it. So it's sort of a very lightweight approach to running the code without needing underlying infrastructure. You don't worry about the underlying infrastructure at all.
Okay, so let's dive into that just a bit deeper, because I think, so you're saying, let me go back to you, that if I'm a coder, I can really do one of 2 things. I can be responsible for spinning up a container doing something, whether that's in a full-time container or a dynamic orchestrated container. I could be responsible for all of that, or maybe I'm not responsible for any of it, except I just get to run some code. The way I think of code when I think of this is I think of a math problem, right? Is here's an algorithm and I've got a bunch of input values and I just want the answer, right? So just tell me the answer, Mr. Mrs.
Right.
Cloud provider.
Yeah, exactly. That's exactly what it is, which is like from a developer's perspective, it's either you're responsible for operating the whole system, or you just provide a snippet of code and you just tell the system when you want that code to run, and you call that code to run. It's a very different sort of approach. From a developer's perspective, it's much easier. You don't have to worry about the underlying infrastructure, but not everything necessarily makes sense to run, in this serverless sort of functional model.
Yeah, I mean, I can see that. Just from a pure cost perspective.
Yeah.
I can see that it doesn't always pay to buy in small quantities. It's sometimes that. But I would make the argument. I actually did make the argument to you pretty early on, Marcus. Is I said, why don't I just spin up a VM and then spin it right back down? Right? I keep doing this dynamic, but I do it like per second or something. And
Right.
So tell them what you told me. Why can't I just do that?
Well, it's partly the hassle of orchestration. It's partly a technical challenge, which is spinning up and down a container that fast for something that's going to run on the order of maybe even less than a second. It might be tens of seconds or a few hundreds of seconds maybe. But spinning up and having an orchestration engine that does that super dynamically is not really how Kubernetes is designed to work. It's not quite that flexible.
Okay.
So those small sort of bite-sized instances of code running, like this serverless really fills a gap that even an orchestrated dynamic model can't really solve well.
Okay, so serverless. So these run on servers, I'm confirming.
Yes.
Okay. So
Yes, there's a server under there.
Thank you. It took us 2 hours a few weeks ago to get to that. So serverless is about perspective, right?
Yes.
To a cloud provider, it's not a serverless thing to them, right? Because they own physical bare metal that is a server. But then
Right.
to the developer, that was the light bulb moment for me. To the developer, it's serverless. Correct? From their perspective, there is no container, there's no VM, there's none of that. It just, I don't have to do anything. I'm not building a server from a
Right.
logical perspective. I'm just running code.
Yeah, that's a really good way to think about it. It's really serverless is a perspective. The cloud provider is still running servers. They're just making they're making the compute the task of those servers available in a different way on an on-demand basis. From a developer's perspective, it's serverless because all I got to do is provide code and call an API.
Okay. So the next question that comes to mind is I'm going to draw again. I'm going to build, I'm going to build some kind of awesome, machine learning AI, I'm going to put a bunch of slashes, I'm going to build everything here. I'm going to build, a cloud like Extreme has, which has hundreds, if not thousands of different functions. How or who decides where that goes? So
Yeah.
maybe it's a feature or it's a new function or it's something. Who decides? Is it serverless? Is it dynamic? Is it always on?
Right. It's a good question. It's actually a combination of different people with different roles. So one would be a software architect to sort of look at the technical functionality of the code and say, does it make sense to even run this as serverless, just from a technical perspective, or is this something that always needs to be on, where this sort of bite-sized, event-driven, serverless nature doesn't work for that code or that feature of the system? There's also sort of an operational piece to this where you look at DevOps to say like how much dynamic orchestration makes sense for a certain feature. And then there's also sort of like a business product ownership, what we call a PLM or a product line manager, that would have to look at code or not look at code, but look at a system and say, does it make sense? The amount of time it's going to take us to convert code or write code in serverless and manage this very dynamic now distributed code, does it make sense from a prioritization and effort perspective to use serverless for those features? And does it save us enough money to justify it from a business perspective? All of those things are important.
Before Extreme, my previous employer was a cloud analytics provider. And I remember going through, they would come back and say, oh, we saved a bunch of money. We reorchestrated some things in the cloud and it ended up saving us money. So maybe a poor assumption, but I think one of the things they were doing is moving, between these, three things we've talked about. And I know that that's not always easy to do, but they've moved between these to gain some optimizations.
Yeah, I mean, serverless to me is just one more sort of tool in the tool set of building cloud technologies. And I know that as we talk through this, obviously I was learning it and learning how to explain it more effectively. And you were asking so many great questions along the way that make you realize serverless is not really serverless, but it depends on perspective. And so it's this has been a good conversation just to kind of sharpen the way that we think about technology and how different cloud technologies are used.
Yeah, and I very much appreciate your continued patience with me with that, and I hope it paid off. I hope everyone out there understands serverless better and these functions as a service. So thanks, Marcus.
Yeah, my pleasure, man. It's been fun. Thanks everyone for joining us, and we'll see you next time.